Hi students! In this video, I'm going to be walking you through my tips and tricks to score well on your lab reports. Now, other instructors may have slightly different approaches, but I would say that the general information that I'm sharing in this video are applicable to most students. And so, in order for us to be able to evaluate your reports, we want you to have these components. And several of these are also going to make up your pre-lab notebook entry. So you would have these written even before you come into the lab to do your experiment. These include your headings, which has your name, your lab partner's full name, and I'm emphasizing full name because sometimes there are students who have the same name in a section, and we want to make sure that we correlate to the correct student, the title of the experiment, and the date that you conducted that experiment. This is followed by your purpose, the procedure, and the data sheets. And I'll talk a little bit more about each of these here very shortly. But because these are already in your lab notebook before you even come to do the experiment, the way that you would incorporate these into your lab report would be using clear and well-lit scans of those notebook pages that have that pre-lab notebook entry. Once you have those scans, you're going to incorporate those into your Word document or whatever type of writing software that you tend to use. And you're going to make sure that once you finish the full report, this doesn't make up the full report, but once you do finish up that full report, that you upload that file to both Canvas for Turnitin and to Gradescope, which is where we will give you that detailed feedback. And you want to ensure that your scans are in the correct orientation. What I mean by that is that if you have your scan that is in portrait view for your lab notebook, you want to make sure that that scan is in portrait view in your lab report document. A full page of your lab notebook should be represented as a full page in the report. Sometimes students aim to preserve some space and they take a full page of their report and they make it smaller. And that makes it harder for us as instructors to grade your report. So I ask that you incorporate a full page of your lab notebook as a full page from that Word document. If you need to correct something from your pre-lab, maybe you wrote things in the wrong tense, maybe you're not happy with how your purpose sounded, whatever that correction might be, you might want to retype that section. So whatever the component was, you could do the purpose, the procedures, your data sheets. You still need to include scans of your original work, even if you decide that you want to retype that original content. We need to see that it was in your notebook in the first place. And as a guideline, this will be repeated throughout this discussion, but any typed content I want to see as single spaced. It helps me to be able to see things as much as possible on a single page rather than on multiple different pages because you'll refer to data. And sometimes I want to make sure that the number that you have here is consistent with the data that you're talking about downstream. Now, sometimes students ask, is a photo really that bad for the lab reports? And while we may be able to read it, a scan usually ensures that we're able to read the information. Part of the reason is because photos sometimes have shadows that are unwanted. Sometimes there are unintended background components that make it into the photo or things that cover your content of your lab notebook that make it into the photo. And so we prefer scans. So these scans can be either taken with an actual hardware scanner, but this one was taken with my iPhone. And so you can choose whatever method works for you. We just want to make sure that that scan is a full page. It usually gives us a great resolution to be able to review your lab report. And that helps us to be able to grade more efficiently as well. Now, those headings one of the biggest pitfalls that I see is that sometimes students don't include those headings on every single page of the lab notebook entry, and they need to be there. So make sure that your headings are there and they're complete on each of those pre-lab notebook pages. The purpose should be 2 to 3 sentences and written in third person past tense. So some things that the purpose might address include the hypothesis that you're testing and the experiment objectives, where you relate those to the principles that are being explored within the experiment. A lot of times this is involving answering a couple of questions, like why was the experiment conducted? Not only in the sense of what you're doing in the laboratory and why you're doing that, but how could this be applied outside of the lab into the real world? And another question that this often addresses is what problem or research question are you answering? So these guidelines should help you with putting those 2 to 3 sentences together. Now let's evaluate a couple of examples of purpose statements. So we're going to compare report 1 to report 2. Where report 1 reads, the objective of this experiment is to determine the densities of known concentrations of sucrose standards by measuring the weight of a given volume of solution. Acquisition of the standard data will facilitate the determination of sucrose content in an unknown beverage. And comparing that to the second example, make sucrose solutions, check their densities, find the sucrose concentration of an unknown beverage. If we're looking at these two and comparing them, which one would receive more credit? I would say report 1. But this doesn't come without flaws because the tone that we're looking for is third person past tense. And there are different tenses that are included here. For instance, the objective of this experiment is to determine, or acquisition of the standard data will facilitate the determination of sucrose content. And so you want to make sure that you use the appropriate voice in your writing so that you can get that full credit. Even though this is overall giving a sense of what the experiment was about, why you did it, the only big red flag I'm seeing is the tense. Now, looking at the procedure, the format of the procedure as you come into the lab should be an outline or a bulleted list of the steps that are performed. You don't want to include your procedure in paragraph form. And again, the voice here in your report should be third person past tense. The steps of the protocol used to collect the data and quantities that you are recording are what you're going to include in that procedure. And a lot of times there might be aspects that you want to make sure that you specify. For instance, if you made an error and you want to include that, not if you want to include that, you want to include that in your report and have that in your lab notebook as you're collecting data so that you can take that into consideration as you analyze your results. So when modifications take place and things of that nature, you want to record that in your lab notebook as well. Your data sheets and calculations somewhat go hand in hand, so they're both highlighted here. Your data sheets are, of course, the data that you collect during your experiment, and you want to make sure that you report your data appropriately. One of the biggest pitfalls I see here is with regard to mass measurements. So sometimes students will see, oh, my mass measurement says 1.110 gram. And instead of recording all 4 of those digits, you would record only 1.11 grams. And we want to make sure that we're taking into account significant figures throughout your calculations, and that can impact your downstream calculations in significant figures. So that would result in a deduction. So making sure that you incorporate all of the digits that you possibly can according to the measurements that you're making. Your data sheets and calculations are often going to have analysis of your raw data and an analysis of whatever errors or uncertainty that your measurements present. So with your calculations in terms of formatting, You want to show the general equation or formula that you're using. And then you also want to provide one worked example. We don't need to see 20 of the same type of equation, but we do need to see one at least in your report. And so taking a look at an example of this, we've got a graph to the left here. And sometimes your data sheets and your workup involves creating graphs. And so the prompt here is to calculate the percentages of sucrose of apple juice, which you identified has a density of 1.579 grams per milliliter, and milk, which has a density of 0.261 grams per milliliter. So in one report, maybe a student indicates you set 1.579 grams per milliliter equal to the Y value in the equation of the line, and the equation is listed here. You subtract 1.005 from both sides, then divide by 0.0131. The X value is equal to 43.8167% sucrose. Taking into account significant figures, the percentage of sucrose is 43.8%. And we're going to compare this to report 2, where the sample calculation for sucrose content in apple juice is shown. The equation is shown. How the density got plugged into that equation is indicated here. And the work to complete the calculation is shown, and the final answer is highlighted. Comparing these two, while they arrive to the same location and in general feature the same information, the one that is going to receive full credit is going to be report 2, because the prompt is to calculate, not to describe in written terms. So we want to see your work, and this is honestly simpler for you all to provide. And so part of the reason I'm emphasizing as well that in the calculations you're showing either your equation or the formula used is that this isn't like a traditional equation. For instance, if you're trying to illustrate an average where you would have just a generalized equation, what this is doing is it's taking the equation of the line that is relevant from the data, and that's acceptable to show how your calculations work, as long as you are giving it some sort of title that's related to that particular data set. That way we can identify these two things go together. That's going to help us as instructors if you have some sort of title for that calculation to indicate what data set that corresponds to. Your discussion is probably the longest component of your after lab work. And so I can't even fit all of the information in my little blue box on this slide. So I've made it its own slide. The length is usually a few paragraphs, and that number of paragraphs, it really varies from student to student. These are going to be typed paragraphs that are written in third person past tense. And again, any type of typing that you're going to do is going to be single spaced. As an overview of what the discussion is, it's a summary that provides adequate detail of the significance of the experiment's major outcomes by connecting that purpose that you wrote before you did the lab to the results that you collected. So the general overview of your discussion is that you discuss the purpose, not necessarily incorporating it word for word from your original purpose, but just giving a frame of why you've done the experiment in your discussion to start out as an introduction. And then you're briefly going to talk about the methods that you used to achieve your purpose. So maybe you performed a titration, maybe you used gravimetric analysis. So whatever method that is, you want to include that. And a lot of times there's more than one method. Comment on your key results. So this is going to be the most critical part of that discussion. And that kind of goes hand in hand with interpreting those results. You don't just want to say, my percentage of sucrose in apple juice was 43.8%. We saw that in your data and calculations. We want to know what that means in terms of why that result is relevant. So interpretation of those results is going to be the component that probably takes the longest time, is trying to assess why that result is relevant. Explaining any unexpected findings, because sometimes you get a surprise in your results, and thinking about why that might be. You'll also want to identify and comment on any trends in your data. A lot of times we'll give you a structure, for instance, going from 0% of a solution to 5% to 10%. And you can compare those different results and talk about if there is a trend, or maybe there's not a trend in that data. Identify any possible sources of error and comment on how they might impact your analysis of your results. In general, you want at least 3 sources of experimental error that you might be able to identify, and then suggest how the experiment could have been improved. So thinking about mistakes that you made in terms of maybe there was a modification that wasn't incorporated, and so that has impacted your results. So thinking about ways that your yield could have been better, maybe by using better technique or what have you. So this is an assessment of an excerpt of the discussion because, as I mentioned, you're going to have a few different paragraphs. So this one reads, "My partner and I are carrying out the exploring density experiment in order to assess the sucrose concentration in an unknown relative to sucrose standards. We are performing the experiment by weighing known volumes of sucrose solutions. I'm plotting the data to correlate the weight of the sucrose solution and the volume such that the density was provided by the slope. These data demonstrated that the density of sucrose standards increased proportionately with sucrose concentration." Now, in terms of content, this discussion is giving a lot of good information. It's talking about the purpose of the experiment. It's also including aspects of the methods, like plotting the data, and even how your analysis was performed. The density was provided by the slope. Now, there are some other errors, though, even though we are, and just to take a step back, the density of sucrose standards increases proportionately. So this is looking at a trend in the data, which is great. But there are some fallbacks here. My partner and I, so looking at personal pronouns, we, I'm, contraction. Contractions are not included in academic writing. The tense, carrying out, performing, plotting. So making sure that you keep in your third person past tense voice of your discussion and whatever academic writing that you're doing. So if we were to improve this, you might see something like this. The exploring density experiment was carried out to assess the sucrose concentration in an unknown relative to sucrose standards. The data were acquired by weighing known volumes of sucrose solutions. The weight of the sucrose solution and the volume were correlated such that the density of the solution was provided by the slope. These data demonstrated that the density of sucrose standards increased proportionately with sucrose concentration. And that's much improved because we've got rid of the present tense, we've got rid of the personal pronouns. And so that would be on the right track for getting your discussion done. Conclusion. So this is usually one paragraph. It's still in third person, past tense, single spaced formatting. And this is going to be your take home message, usually some sort of highlight of your main findings, an answer to the research question that you indicated in your purpose. You want to talk about any limitations that are relevant in terms of your analysis of your research or your experiment, and summarize why the experiment has contributed to your understanding of the problem. So how it's addressed that purpose, how it's addressed the hypothesis that you were testing. An example conclusion includes the exploring density experiment highlighted the scientific method of using a set of standards to relate to an unknown for quantification. This laboratory exercise offered the opportunity to examine the density of various sucrose solutions. Despite the limitations set by the uncertainty of the balance in glassware, the density of each sample was evaluated to fall within the range of 0.989 grams per milliliter and 1.46 grams per milliliter for the 0 and 60% sucrose samples, respectively. Given these findings, the apple juice was determined to contain 43.8% sucrose. Mastery of the principles in this analysis are applicable in future analytical chemistry experiments. And so this conclusion has given a few things. It gives an overview of why the experiment was conducted and what the objective was. Some of the key findings in terms of not going through each and every data set that you report on your data sheets, but just giving highlights as in terms of like trends. And then finally, taking a look at why this experiment can be applicable to other areas of chemistry, other areas of science, or even that real world view, how it can be useful outside of science. You could think about food chemistry and how this might be important, for instance, in looking at nutrition facts. And so these are just a few recommendations here. And lastly, the post-lab questions. So these are relevant for some labs, but not all of them. So you want to check and consult your instructor if you're not sure if the post-lab questions are required. And so you'll want to make sure that you complete those. Typing is perfectly fine, you can handwrite them. And one other thing I should mention is that the calculations can also be handwritten if you prefer. Just make sure that that's clear handwriting. And so those components are two things that you do outside of lab. And so just as a final reminder, lab reports are due 7 days after the conducted experiment at 11:55 p.m. You do have options to extend that if you are unable to submit at that deadline, but it does come with deductions. So you can check out our syllabus to take a look at how that comes into play. We take lab reports up to 72 hours after that initial deadline. So please feel free to reach out to us as instructors if you have any questions about how your report should be constructed.